welcome back. We're starting a new unit today. It's our solving equations unit. It's a pretty big unit, but it's a really important one. So we're going to take our time to really master a lot of this content. So today you're going to be able to define parts of equations and be able to combine like terms. That's our first introduction to solving. We have to know a lot of this vocabulary going on throughout the rest of the semester in this unit. So let's go ahead and get started. So defining parts of equations. So if you can look at the graphic here, you can see that I've sort of given you this negative 2x minus 3 equals 21, and we're going to label what we call all of these different types of numbers, variables, and combinations of numbers and variables. So the first one I want to do is the variable, which we've already done before. We did it in the last unit, but it can't hurt to do it again. So a variable, again, is a symbol for an unknown value. Okay, and in this infographic, we can see, and I'm going to highlight it, the variable is right there. That variable, that x is our variable. Okay, so it's a symbol for an unknown value, typically a letter. Okay, I'm going to even put that. Oh, not value, a letter. So that's our variable. The next thing I want to go to is actually a constant. So this word down here, constant at the very bottom, is just a number by itself. Connected to it, just a number by itself. And in this example, this negative 3 is a constant, and so is this 21. We don't have an x with it. There's no exponents with it. It's just that number by itself. Okay. Then the next vocab I want to talk about is this word term. So term is something that's going to come up a lot. And a term is either a single number. In fact, let's say a term is a constant or variable. Or, big or, it's numbers and variables multiplied together. And they're separated by plus or minus signs. So if we look at the graphic, there's a few terms in here. There's this negative 2x is considered a term. It's got a negative 2 and an x kind of right next to each other. The negative 2 and the x are not separated by a plus or a minus, so that whole thing is called a term. Also, this negative 3 can be considered a term, and so can the 21 be considered a term. It's both a term and a constant. A constant is always a term. Okay, so we can name it both things. Okay. The next one I want to talk about is a coefficient. So a coefficient is that number used to multiply a variable. A coefficient is also considered the number in front. And I'm going to give a couple examples. Okay, the example in the infographic here is this negative 2. Okay, that negative 2 right here, just the negative 2, not the x, is considered a coefficient. Okay, so some other examples of a coefficient would be something like if I had 6x, then the 6 would be my coefficient. If I had something, sorry, I had the wrong pen there. If I have just x by itself, my coefficient is actually going to be this invisible thing in front, and that invisible thing in front is a, oh my gosh, I can't get that pen to work, is actually a 1. So anytime you have an X or an A or whatever letter, there's an invisible 1 in front of it, and that's going to be the coefficient of 1. That's a really important thing, but can really be tricky. And then the last example I'm going to use is, say, what if we have something like 2 variables next to each other? Well, this x squared, this a right here, that would be considered our coefficient. So while it's not always a number, sometimes it can be a variable. We won't see that very often in this learning target, but it will come up later, so just to keep that in mind. Okay, we've got 2 more words to define, and let's go ahead and do expression, which is one we've done before. Okay, so remembering that expression are now, we're going to call it, I keep doing that with my pen. I got to cut that out. So we can now say an expression are terms grouped together. By plus and minus signs. Critical thing here is that there is no equal sign. Okay, so if I've got in my infographic here, this whole thing right here is considered an expression. Okay, because it's got that negative 2x minus 3, it's terms grouped together by plus or minus signs. And finally, let's go to equation, which is what this whole unit's about, is solving equations. So an equation says that 2 expressions are equal. Key here is that it has an equal sign. Okay? So that would be this whole thing we're looking at. The negative 2x minus 3 equals 21 is our equation. So this is a lot of vocabulary, but it's vocabulary I'm going to be saying in class, vocabulary I'm going to be asking you to know, and vocabulary I'm going to be asking you to say in class. Okay? So if any point, again, you're confused, you're not sure what these definitions are, please come ask me, because it's really critical that we know these words that I'm saying in class. So let's take a look at what examples of what I'd like you to be able to do with these words. So example 1, identify whether each problem is an equation or expression by circling the correct option. So that's the first step I'm going to do. Then determine all variables, terms, coefficients, and constants. So my first problem is 2x squared plus 4x plus 4 equals 2. Since this has a equal sign, that is going to be an equation. My variables are x and x, so I just have one variable of x. My terms are all of the coefficients and variables separated by plus or minus signs. So that right there is a term, 4x is a term, 4 is a term, and 2 is a term. So I have 2x squared, 4x, 4, and 2. Okay. My coefficients, I'll highlight them here in pink. My coefficients are that 2 and that 4 right there. So coefficients are going to be 2 and 4. And then my constants, let's highlight that in this orange color, are that 2 and that 4. So that means my constants are 2, 4. Example B, I've got negative 4a minus b plus 3 plus 1. I don't see an equal sign, so that's going to tell me that this is just one big expression. There's no equal sign. My variables, I've got an a here, a b, and a c are my variables, so a, b, and c. My terms are negative 4a, negative b, you keep the sign with the term, 3c, and positive 1. So I've got negative 4a, you keep the sign with it, negative b, keep the sign, that's a positive 3c, and the number 1. Those are all of my terms. My coefficients are the numbers in front of the variables, and I've got 3 of them. I've got the -4, I've got this negative b, which I can draw in a 1 here in front of that b, and then say that that -1 is my coefficient, and I've got 3 as my coefficient. So my coefficients are going to be -4, -1, and 3. That one's kind of tricky because of that invisible 1 and those signs. And then I've got one constant, and that constant is that 1 at the very end. Okay. Now I want you to look at the next 2 problems. I want you to pause the video. Whenever you see this you try, that means it's your turn to pause the video, try the problem, unpause, and then you'll see the solution. So go ahead and pause the video, and when you're done, you can go ahead and see what the answers are. So go ahead and pause now. Okay, hopefully you've paused so you can see what the solutions are. For this example, we're going to have this be an expression. It's got no equal sign. My variables are x, y, and z. I always make my z's with a line through them so they don't look like a 2. Your terms should have been 4x squared, -7y, and 2z and -1. Your coefficients should have been that 4 in front of the x squared, the -7 in front of the y, and the 2 in front of the z. And your constant should just be that -1 at the end. For part B, that is going to be an equation. It has an equal sign. Your variables are x and y. I've got 3 terms, y, x, and -3. My coefficients in this case are those invisible ones, and I would encourage you to draw them in. 1y, 1x, so your coefficients are 1 and 1. We can just write 1 just once if we want, since they're both the same. And then my constant is going to be that -3. If you did these and got them incorrect, please come ask me. Pause the video, come ask me in class. If you're watching it at home, make a mark to come ask me. That's the whole point of these videos, is that you are in control of your learning. Okay. So now that we can identify these things in our equations and expressions, we want to be able to combine terms that are like within these equations and expressions. It's going to lead up to solving. So like terms, if we want to define them, are terms whose variables and exponents are the same. So in example 2, I've got several sets of terms. So in A, I've got -2x and 4x, and I want to determine whether they're like or not. These terms are like because they just have an x and an x, and those are the exact same. When we combine like terms, we add the coefficients. Okay, and we're going to get to that in a little bit, but for right now, I want us to be able to say yes or no here. Is -2x and 4x like? Yes, they are. I'll do a different color. Okay, how about B? 3a and 3b. I've got an a here and a b here. Those are not the same. So these are not like. For letter C, I've got an x squared and I've got a c squared. While they both are squared, that means that those are the same. X and c are not the same, so that is a no, they are not like terms. Letter D, y squared and 2y squared. They both have a y, and they both have a squared, so that is a yes. It is okay if the coefficients are different. It doesn't matter if the coefficients are same, just that the variables and exponents are the same. E is a little tricky. E, I have an a and a b, and I also have an a and a b. But in this example, the a in the first one is not squared, but the a in the second one is. And the b in the first one's squared, but the b in the second one isn't. So that is a no. They have to be exactly the same. Okay. And in my last one, I've got an x squared and an x squared, so that's going to be a yes. So that's determining whether or not like terms are like or not like. Okay. So here's another you try. I want you to pause the video and take a look at A and B and determine whether those two terms are like or not like. So pause the video, write down what you think, and then unpause the video when you're ready and see if you're correct or incorrect. So go ahead and pause. Okay, so hopefully you've taken a second to do these two problems. For letter A, you should have gotten a yes. And for letter B, you should have gotten a no. In letter B, you've got x, y, and the other one's x. Well, the other one doesn't have a y, so they cannot be like. Okay. So now let's talk about combining like terms. And like I said earlier, combining like terms means that you look for like terms. So step one is look for like terms. And step two is that you add the coefficients. So for step one, I'm going to look for my like terms, and I like to use shapes or colors for this. So my like terms in A are 2x and 3x. My like terms are also going to be this -5 and +3. If you're going to use shapes or colors, make sure you highlight or use the same shape with the sign. So 2x and 3x, I'm going to add the 2 plus the 3 to get the 5. Keep the variable the same. So 5x. Then I like to cross out terms I've used just to let myself know, hey, I'm done with them. I don't need to work on them anymore. -5 plus 3 gives me -2. So my answer to A is 5x minus 2. For letter B, it just so happens that all of these are like terms. 3b, 6b, and -b. But the trick here is that I would draw in a -1 right there. So then when you do math in your head, which I don't always encourage, or the calculator, you're going to do 6 plus 3 plus -1, and that is going to give you an 8. And then you just tack the b on with it. That gives you 8b. For letter C, I'm going to use some shapes again. This x squared is a like term with this -6x squared. They both have x, they both have squared, they're like terms. And then -3 and +2 are also like terms. So 2 plus -6 is going to give me -4. Keep the x squared. Done with these two. And -3 plus 2 is -1. So I'm going to get -4x squared minus 1. And finally, D looks like a lot, but if we use our colors or use our shapes, it makes it a lot simpler. So I've got this 5x squared. That's a like term with -8x squared, which is a like term with 4x squared. When I combine those terms together, 5 plus -8 is -3. -3 plus 4 is 1x squared. You don't need to write the 1, but you can if you like. It is invisible, so if you just wrote x squared, that would be okay too. Done with the x squareds. The next things I'm going to look for are my x's. So I've got a 4x, a -7x, and a -8x. Remember to circle that sign. -8 plus -7 is -15. -15 plus 4 is -11x. Keep the variable, change the coefficient. And finally, I've got my constants, -5, -8, and +8. Well, 8 minus 8 is 0, so those cancel out. So I'm just left with that -5. Colors and shapes really help here to combine like terms if that's a strategy you want to use. So speaking of strategies you want to use, the next step is another you try. So I want you to take a minute, pause the video, try A and B, see how you do. So pause the video now and try this problem on your own. Okay, so for letter A, you should have gotten 2A plus 4B. And if you have questions on how or why, if you got that wrong, again, please come ask. For part B, you should have gotten 14x plus 2y plus 4. That should be your answer for letter B. Again, questions, come ask, please. The last thing I want us to be able to do in this learning target is kind of connect what we did in Unit 1 with area and perimeter to Unit 2, where we're now working with variables with area and perimeter. So example 4 says, write an expression, that's the key here, write an expression in simplest form that represents the perimeter. So remembering that perimeter is adding all the sides. So I'm going to first label this side 4x minus 1 because it's the opposite side is going to have the same value. So if one side's 4x minus 1, the other side's 4x minus 1. If this side is 2x plus 3, this side is 2x plus 3. Perimeter is adding up all four sides. So my perimeter is just going to be that 4x minus 1 plus 2x plus 3 plus another 4x minus 1 plus another 2x plus 3. That's how I'd write off the beginning of my perimeter. Then I'm going to now combine like terms like we've been doing. So I've got 4x, 2x, 4x, and 2x are all my like terms. 4 plus 2 is 6. 6 plus 4 is 10. 10 plus 2 is 12. So I have 12x. Then I'm going to do my constants. I've got -1, 3, -1, and 3. And when I add all of those together, I'm going to get a positive 4. So my perimeter is 2x plus 4. I know it's strange that your perimeter is not just a value. It's not like 10 or 20 or some number. It's an expression 12x plus 4. That's still my perimeter in simplest form. Okay? So now go ahead and start your practice. Good luck. If you have any questions, you know what to do.